Cool. So how's everybody doing?
Good.
Let me freeze up. Well, guys, we almost made it through a full week, huh? Hello?
Bueller.
Bueller.
Nobody's gonna forget that reference. I didn't say that you were 5 years old, but as the years progress, the amount of students who understand the reference goes lower and lower.
Okay.
Lower. I don't think everybody knows Ferris Bueller.
All right. Guys, girls, what is TCP? We've talked about it before. I need someone to say what it is without reading it off the script. Right.
The tool center point.
The tool center point. Tell me more about what it is. If I order a robot, pull it out of the crate. What is the TCP on that robot that I just bought? Next. So does it have a gripper on it? No. What does it have? What?
What is that?
What is that?
Tool zero.
Tool zero. Exactly. So essentially, it doesn't have end of arm tooling, right? It doesn't have a gripper. It doesn't have a suction cup. It doesn't have anything that can functionally grab anything, pull anything, right?
So when it's out of the box, and that's your tool zero, and you program like a rob target, where is the robot? If you're going to tell the robot to go to a certain area, which part of the robot's going to go there? That part, right? Tool zero. Even if there's no arm on the end or no gripper on the end.
So you guys, just like when we're learning about milling, you guys got to think in multiple coordinate systems, okay? We have a world coordinate system, which is basically the center of the base of the robot. We have a world coordinate system. Then you have tool zero's coordinate system, which is the base plate. And that's what it's showing here with this triad. All right? So when we start activating tools, like when you guys are jogging, you're activating different tools like T-gripper and T-pen. Now we've got another coordinate system. Does this bring back memories from when we were working on the mill? You guys had G53 and G54. You were able to do different things on the bed of the work surface, or you had different tools that were different lengths. This is the same exact thing. You've got different tools with different orientations and different lengths, and that is a different coordinate system. So today, we're going to have you guys create a different tool center point with a different point in space. And that's going to be our task for today. All right?
So the one that we're going to be doing today is with the pen tool, but if you can kind of expand your mind outside of education and think about industry, does every robot that's being used in industry have a tool that has like a point at the end of it? No, right? So there's some robots that are used to like pick up a pallet or pick up something, or it doesn't have a point at the end. So the tool center points for those more advanced end-of-arm tools might not be defined with just a point, right? But today we're going to take a little bit of an easier route and just do a pen.
And when you're writing your route targets, what are the variables that you're putting into your instruction lines? So like for instance, p-pounds. What are you adding after p-pounds? What did you see? What? Okay, so that might be the move instruction, so move J. And then what else comes after that? How are we telling it to move between the points? What other instruction information are we giving? V, velocity, right? And so when we're describing velocity, it's the tool center point velocity that you're describing, not the axis. All right? So when this point of the tool, we'll imagine that this is the pen, when it's going between those route targets, that's the velocity the robot is trying to achieve. Okay? As it moves. Now, it may not achieve that depending on where it's moving through space, but it's going to try to achieve that velocity. What other factors besides velocity? Zone. Good. Your zone data is also described in the instruction line. All right? So general measurements are needed when you define a tool, because you might have, or you probably are going to have multiple tools on your end of arm. You're going to have maybe a suction cup like we have out there, or you're going to have a gripper, you might grab a pen. So if you notice when we did our first drawing activity, some of those tool center points weren't exactly where they were needed to be. Okay? Maybe the pen moved, maybe it was too far up. What different jogging modes did we have out there in the robot? Everybody help me out here. What jogging modes do we have?
When you're manually moving and jogging the robot around, what were the options that you choose here?
So you got linear, so the TCP can move up in the Z, X side by side, Y.
Special.
You can reorientate. What are you reorientating around when you go to reorientate?
TCP. That's why it's important to have a proper TCP, especially when you're working on those kind of fine motor skills with the robot. Maybe you're working on an area, think of like soldering, or a robot that's working on like an electrical circuit. You need that robot to be exact, and that's why the TCP is so important.
And then you have your axis jobs, right? So what we're going to be able to do is we're going to be able to define where in space this TCP exists in X, Y, and Z, but also I could have a point in space, but who knows where the orientation is, right? So we have to define this tool not only where the tool center point is, but also where the orientation is, okay? Those are the quaternion locations as well. If you're going to open up the tool data in your controller, you're going to see a lot of information, a lot of numerical data showing X, Y, Z, but also the rotational data that shows how it's orientated. If you do this right, if you define it correctly, you're going to get a value that's going to help allow you to orientate it around a point, and it's going to pivot, and it's going to allow you to use that tool more effectively.
So Adrian, the closer or the most precise that you make the TCP, the more accurate your reorientate is going to be. So you should technically be able to take like a pin, if you're really, really good, take a pin, put the pin vertical, and have the robot reorientate and not move from the tip of that pin. That's if you're really, really good. It's kind of hard to get there though.
So one of our next Robot Studio activities is going to be, you're going to bring in a program, the program that you wrote last lab, where you guys drew that shape, right? The problem is going to be that we used T-Pen out there, right, to draw. You're going to bring it into Robot Studio. The issue is that Robot Studio does not have the T-Pen geometry in Robot Studio. So what do you think is going to happen when we load our rapid code into Robot Studio and you try to run it in your station? What do you think is going to happen? When it tries to find that path that you guys created and it looks for T-Pen and it's not there. What do you think is going to happen to the robot configurations when it tries to trace that path? What do you think? It's going to do what? It might hit the table, but think about when you wrote that program and it followed that path to trace that shape, it was using the tool data, wasn't it? To define where in space the tip of the pen was and the orientation of the pen. Well, all of a sudden you load it into Robot Studio.
It's not there.
And that pen isn't there anymore, right? So is it going to be able to orientate its axes and the tool center point anymore? No.
No, it's going to give you an alarm. It's going to give you an error.
It's going to say,
Notification.
I don't see that tool anymore. It's not there. So it's not going to know how to orientate something that doesn't exist. Okay? So being able to match your tools between your station in Robot Studio and in your rapid program out there in the robots is going to be essential. Right? Because all that geometry has to go together, has to stay the same.
And the names, the syntax have to stay the same.
Syntax is important. Geometry is important. So here's how we're going to do this. And I have, we have added procedure sheets because we don't expect you to remember and memorize all of these procedures the first time you run through them. Okay? So we're going to pull this up. We're going to walk you through it out here. And we're going to go out in the lab and we're going to walk you through it. Everybody in here is going to have to create their own tool. Okay? So the pen tool is going to be loaded in all the robots. And basically what you're going to do is you are going to bring the pen down to one of these yellow rods, steel rods that we have in the peg holes on the table. Kind of like what you see on this picture. You are going to bring the pen down with the robot arm and you're going to touch the tip at 4 different random angles, you're going to touch that tip as close as you can possibly get it. You're going to have that door open. You're going to have to really get down, you're going to have to look. The closer you get it, the more accurate you are as you define those 4 positions, the better that tool center point is going to be. Because the 5th position is going to be an elongating position where you draw it out in the Z direction. So this picture kind of shows you what we're talking about, where you have 4 different positions angled, touching the tip, and that 5th position is where you draw it out to define the Z direction.
An important factor here is these yellow pegs that we made, these metal pegs, you don't want them to move. So we're going to put them in the holes in the table. You're going to jog the robot around. You're going to define 4 different points in the menu we're going to show you right here. And that's going to tell the robot and calculate where that tool center point is. Now it's important for those 4 random points that you're not using the move linear command to change the point locations. It's best to create kind of a diverse angles with all those different joints. So use the joint jog, rotate those joints around maybe to a different location, and then record a different point.
Yeah, okay. and he's right. I think you guys have used your jogging quite a bit, but I think it's at this point that you've got to get more precise with your jogging and you're navigating the jogging screen. So,
I'll click.
Yeah, when you're first up there and you got the robot at the 0 in the home position, you're going to want to get that robot down so that the pen tool is at that angle. Where's those rods here? Yeah, so your robot's going to be at 0, 0, 0, 90, 0. Pen's going to be out. You're going to want to probably use and switch to an axis job.
Right.
Okay?
So when we were out there, when we were practicing and working on this, the first thing that we like to do when we put that in, we put the yellow steel rod in
the table.
First, click on jogging. So we have this jogging window open down here, kind of like a tab in Chrome or Firefox. Then that allows you to kind of keep an eye on what jogging system you're using. Then what we're going to do is go back here, and we're going to click on Program Editor. Data, sorry. Program Data. Program Data. Tool Data. Double click it.
Double click on Tool Data.
Okay. Now, essentially, guys, we're creating a new tool. Right?
That's all the tools that are currently in the system. So you're going to go out there, you're going to see, I think, 4 tools in the system. Because our robots are already set up with a pen tool, a gripper tool, a vacuum, and tool 0.
So we talked about how important syntax is in coding. So because we have so many classes using these robots, we have to be careful how we name our tools. So when we're naming our new tool, we're going to use lowercase t, capital P, E-N for pen. Then because you guys are in period 2, you're going to put the number 2, and then you're going to put your initials in capital letters.
So I'd be MG.
MG.
So that way, when you guys all build your tools, we're going to be able to differentiate which tools are in which class and whose tool is what. Okay?
After you have your tool name correct, again, be careful with the capital letters, hit OK. We need to make sure that our scope is global, our storage type is persistent, our task is trob, and most importantly, our module is in the main module.
Main module.
Okay?
Main module.
Yep. Don't worry about dimension right now. Just click OK. So look, we have our new tool created.
Now we're going to go ahead and we're going to edit that tool. Once we edit it, the first thing you're going to want to do is you're going to want to change the value of it. So,
change value.
Here's the deal. Out there in industry, first of all, they're probably not going to be using pens to draw things, right? What are they going to do in industry? Give me an example of when they're going to use a robot in industry. Think about IMTS. What did you see out there? What were they doing? What were they picking up? Give me something impressive. Cars, right? They're picking up cars. They're picking up blocks of steel. So some of the things, some of the arms that they had, the end of arm tooling, was heavy. So that's going to affect the robot substantially, right? The weight of those end of arm tools. So we need to go in here and we need to tell it how much mass that tool, the end of arm tooling has. How heavy is it?
First thing that you do, scroll down,
change value, go down, and find the mass, and tell it.
Whoops, I think I passed that.
Yeah,
There
right
we
there.
go.
Tell it how heavy it is. Now here's the thing, guys. We're doing pens. So we can kind of like cheat a little bit and just give it a fictitious number because we're counting not only the pen, but the holder of the pen. So we're going to use a fictitious number. We're going to go ahead and put in 2. 2. Because it's not going to affect our velocity of our robot moving the pen around in the air. But if I'm picking up really heavy stuff with a big heavy end of arm tool, then it's going to make a huge difference. But we're going to just throw in 2.
Right.
The other thing that's going to make a difference is center of gravity. Because that's going to throw things off. If you ever picked up something heavy, especially something that may not be like balanced or have mass that's centered, you notice that it makes a difference. All right? So now we're going to go down to the Z, assuming that it's something that's symmetrical. We're going to go ahead and put in the number 50 for 50 millimeters, showing how far out the center of gravity is away from the center point of that coordinate system.
So even though there's all, guys, pay attention to this, because this is where you can get caught here. Even though there's all of this data in the tool, before we do anything, all we're going to do is change the mass to 2 and the Z to 50.
50. Right, Marco?
Yeah.
Nice. Love it.
Okay? And then we're going to click OK.
Boom.
Okay? And it's filling out some of this data.
So now it just knows the name of the tool, it knows the mass of the tool, and it knows the center of gravity of the tool. But it has no idea where it is in space, right? It could be, you know, at any point in space. So now we're going to go ahead and we're going to hit edit, and we're going to define the tool.
Yes.
Right?
So this is what we were talking about with all these different points. Now before we go and start setting things, we need to select the method that we're using to define the TCP.
And I've made this mistake before. I started defining points, but you have to make sure the method is correct.
Right.
So up there, make sure you use, drop it down,
Drop down, TCP and Z.
which is 4 points and 1 Z elongator. Okay? So for what we're doing, that is the desired method, right? Make sure you don't forget that.
So here's what we do. We have this window open. Think about being in Chrome, right? Multitasking. We have this window open. We're ready to start setting our 4 points. We're not going to close it. All we're going to do is skip over down here to jogging. We're going to jog our robot over to the our steel yellow rod. We are going to switch to axis jog, and we are going to start jogging our robot close to that point. Now, when you start getting close, so you don't crash into it, you're going to want to activate your little steps here.
You guys remember the step? A lot of you guys were in step mode while you were jogging, and you called us over and said, "My robot's not moving." Right?
It was.
It was moving, but it was
Very
moving
slow.
in small increments, right? If you're moving in really small increments and you want to bring those increments up, how do you do that? Quick set menu. Quick set menu, and you can go to your increments and you can bring your increments up, right?
Small, medium, large.
I would recommend medium,
Yeah.
because your small increments are going to be here for a week trying to set up your TCP, right? And we're not doing production stuff. So
All right, guys, can you be our demo robot for right now? Your hand.
I can be a dummy.
Okay, so
dummy robot.
you guys are going to use the controls. You're going to jog on over to get close.
So axis, right? It's going to be a little bit difficult to get it, but you're going to at least be able to position the configuration close.
When you get close, you're going to go incremental. You're going to start jogging
Probably,
closer.
what would be the best, once you have your axis configuration kind of close, what would be the best method of jogging once you're in the ballpark? What would you do? So it's going to linear.
Yeah.
Because now your linear movements, now you can really kind of get it close, and you should be in step mode. Because now you can open up that door, get your eyeballs close, and bring
Touch it.
Touching.
Okay, so once you have it touched, you're going to go back over down here into program data. You're going to click on point 1, and you're going to hit modify.
Modifying.
Okay? You're going to hit modify, and it says modified. Then you're going to go back to jogging. You're probably going to want to jog your robot up and away from that point so you don't crash. So jog your robot up, maybe to Z. Switch to joint jog. Reconfigure the joints to give it a different position. Maybe jog right back down. Slowly touch the tip. Go back to program data. Modify position again. You're going to do that 3 more times. Up, over, down. Modify, up, over, down.
Pretty good, isn't it?
Yeah, that's pretty good. Are you touching? I can't see.
Sorry.
Down, modify. This is the most important part, guys.
Most important part.
After you're done with point 4, there's something called the elongator point, which defines the Z of the tool. So what you need to do is go into jogging. Go into linear jogging, and you want to jog positive in the Z about 1.5 inches. So jog up.
It's going to go along the tool.
That's true. You're right. And
Go
then,
along the tool.
in program data, you're going to click modify.
So it knows the direction of the Z in, remember, that's a separate coordinate system. The tool has its own coordinate system. Separate from the world coordinate system, right?
Now this is the best part. I wonder if it'll calculate it because I haven't really been
It'll
jogging.
fail because
It'll fail.
Yeah, because we didn't actually jog the tool center point even close. So chances are those coordinates were way off, and it's like, whoa, I can't calculate that. But what you're going to do is you're going to get a mean value. We're going to take you guys out here right now. We're going to turn this into a competition.
Yeah. By the way, I won the competition this morning. I beat him. I got a closer mean value.
It's going to do statistical analysis on all those points, and it's going to give you a mean error. As long as it's under 2 millimeters, your mean error, that means it's an acceptable amount of variation.
The smaller the error, the better and the more accurate your TCP is.
So we're going to see who gets the best mean error. Smaller, better. Okay?
Does that kind of make sense, guys? Through a lot of attitude. Bless you. The best way to learn it is by doing it.
Let's all go out there, and let's, you guys are going to watch as we do this out there live, and fire it up. Alright, so what do I do first? I need to go to program data. So, and I get that it's hard to see what I'm doing, but I'm going to go to tool data, and I'm going to create a new tool, and I'm going to name my tool. I'm just going to name it tool 1 because I'm going to delete it right afterwards. This is probably going to turn into a really simple tunnel. Ready? So I'm just going to go ahead and call mine tool 1 just for now. Because right when we're done, we're going to read it, and it makes me go a little bit faster than him.
Tool.
Okay, so tool 1. Now, this is good too, because then you guys can see. Alright, so now I'm going to go edit, and I'm going to change the value, right? And then if I got to scroll down because you're not going to see immediately the mass and the, so there's mass. Just default it to, that's what the procedure sheet is telling us to do. We don't really care because we're not in production.
Okay.
C is going to go to 50. Okay.
This part's
now I can define the tool. So edit, define the tool. This is what I screwed up last period was I forgot to do this.
Yeah, you have to change this first from all your points.
And Z. There's my 4 points. My fifth one is down there, which is the elongator. Now, I'm going to jump right away to my axis jump. So I'm going to go in.
I'm going to go in our program data. Point 1, modifying.
Okay. I can't move my robot. Nope, I'm in step mode.
Go to jogging.
So make sure you guys remember that. Okay? So I'm just going to get it down, kind of in the ballpark. Oh, yes, he's out of working range, folks.
Okay. Because we're in reorient mode.
So right there. So notice how you just got to get it in the ballpark, switch directly to linear mode. All right? Get it within maybe a ½ inch-ish. Go to step. Now if it steps really, really slow,
Flip this around.
That's it.
I'm going to go in the joint mode. I'm going to rotate maybe axis 4. Okay. This way.
what's interesting is I am jogging up and down, and it's not going perfectly straight, so I should probably go to my jogging menu and activate tool 0.
And I might do axis 5 too.
Slot. You gotta be careful that it doesn't get
locked up. We're in such a close position. So
Let's
that's
see if
I want to pick T10.
that fits.
and then maybe I'll like rotate it this way.
Now what?
Once you get the axes the way that you want to, I like to go into linear mode.
And I'm going to change my step mode to go a little bit faster.
This.
Come down here. So we're gonna get it as close.
So, what do you have? What would we have to?
I'm too far away right now, so I want to go in and open this up.
Okay.
I'm going to go
So
into
we probably just have to watch this close, right? So, what I want you to do?
and
Grab
I'm
down,
gonna go
down.
right up to this
You
thing
measure that for me.
and
Touch
touch it right to that tip.
And then we're going to add a little material.
So then I'm going to go to program data.
So this is a little bit bigger. And then we
Modify
can
position.
we're going to go
Back to jog. And I'm going to send it up into Z. Up into Z. And then I'm going to switch my axes to go into axes mode. Let's do a little bit of this. Let's flip our. It doesn't have to be like reverse like this. I'm going to go back into linear mode here. I'm going to come down. Now, if we might get locked up, we'll see. We're okay. We're close here. Jog over. Notice we're in singularity. The robot's locked up. So we don't like that position. So I'm going to have to get out of that by jogging up and switching a bit.
Stress me out, guys.
Maybe let's go back to joint jog. Let's go to let's jog.
I'm going to call that my first point.
Position. Put it in linear mode.
So,
Get it as
status,
close
modify
as we
position.
can.
Okay.
Modify.
Modify.
Over. Modify.
I'm going to bring it up.
Over. Over. Now I'm going to go to the middle.
Rotate it.
Come down.
Something different.
Get as close as we can.
I'm going to go back to my linear.
Down.
I should probably rotate.
Over.
You want to have it at a nice speed.
Right there.
That.
Again, program data. Modify. Go back into jog. Jog up in linear. And sometimes it's also helpful when you send it over to
Step.
step over here.
Modify.
Up. Let's shift this a little bit. Let's come down this way.
Reorientate is a good
This
way.
way.
Because I have an old pen tool active right now as my jogging tool. So if I reorientate, it will work, but it's just not very active. So I'm trying to make it
Come down.
more active.
Incremental.
I'm going back to linear mode.
Over. Over. Over right there. Last one.
Enough. Modify.
Modify. Now here's your Z elongate. So this is very important. You go back into jogging. We want to make sure we go up into Z.
Okay.
And I'm going to just about 5 inches. Then data. Modify. Hit OK. It's going to calculate.
What's your
Right
number?
now, my mean error is. Well, what's yours?
I am not there yet.
Okay, I'll tell it to you. Nah, mine's 0.7. Mine's 745 thousandths. No, it's not. 0.745 millimeters. 0.745. No, it's not.
Tell him, Marty.
That's not pretty big.
I expected more.
So, what's cool about this guy, so when you're done, as we'll wait for him, I guess. If we go into jogging, we have to select the tool that we created. This one.
There we go.
Okay.
Modify. Okay. So I did my fourth point. Now what I'm going to do is in linear.
We get
I'm going
close.
to take off
We
my
get
step
reorientate.
twist negative.
We should be able to go all the way around this
Out.
point.
About 1.5 inches. You're going to modify position. Hit OK.
Keep it right on that.
Mean error.
We got
Check.
0.5.
Lauren!
What'd you get?
Tell
0.54.
Pretty good.
Yes!
And
Leave 5.
Oh.
Good.
okay. So I'm gonna delete the tool. Edit.
As long as it's
Delete.
under 2, it's acceptable.
Yes. Delete this tool, and then you gotta go back to the town.
Alright, so now
Grab that for a while.
go. This is where it
And,
gets cool. You go right
So
to there.
there's all the windows. And to make it a little bit more
I just
difficult
defined
for you
tool
guys,
1, right?
I'm gonna
Good
go to
job.
Program Editor.
Activate tool
We're
1.
gonna go to Debug.
Alright? And then you go to
Routine.
orientate and watch
Go to
it.
Cal.
Everything around that point.
Cool? And close. so somebody can use that robot.
Yeah, if you guys want to mess
Do
around.
you have the other tool? Yellow.
I gotta grab another. Actually, right here.
Hey, you want to make sure that yellow tool's on the right-hand side in the middle peg. Oh, jeez.
No, that was-
Sebastian.
No, I told him to.
That's Guy's fault. It's
all
always
my
Guy's
fault.
You're the guy that opens up his car door and whacks into the car next to him.
No, I hit my head on the top of the car.
You gotta drive away after you do that.
We can delete my tool.
Victory, woo!
What's this?
Make sure your motors are on. Make sure your emergency stops are off.
What's the student pass?
Student.
Type student.
Caps lock is on.
Oh, your name? Did you tell my name? Yeah, we did.
It tells you right there.
Apple has like the little green light on the laptop.
If you haven't noticed, they put it on the screen so when
Just pay attention to the time, guys.
I will, hey, if you want to open them up on those computers, we can put the proc sheets on here. Because they're all on the
Do you
desktop.
have the entire?
I think I did. I believe that I did. Yes, I did. TCP. There you go. Here's some instructions if you forget how to do it. Here's some instructions if you forget how to do it. Okay.
Yeah, not sheets. So,
Why you
just
look at
FYI,
Word?
guys, we got a folder called not sheets. All, never.
Here, Lauren.
Never
In case you guys forget how to do it. You will. Proc sheet for you.
What's the story?
It is touch screen. Don't touch! Yep, system. Yep. Yep. And main module. Good. Good, and then you guys can just scroll through this. Oh, look at that. Scroll through it. Yeah. That's actually the whole thing.
I would switch to reorientate mode and get that thing
Whoa.
Lauren, you were a mess today.
I really don't care.
Wow, that's.
Can you not do that?
It was in 20?
Yeah. Wait, no, 50. 50. Tap, then you want to do new tool. Remember, lowercase t, capital P, E-N.
Always this button.
Lowercase t.
Hey,
Capital
maybe,
P.
What's going on? Do you know what a furry is? Ah,
Make sure you put your period too. T, pen, and where your initials. Where your initials, yeah.
Mr. Steinbach?
Yep.
We're about to do close to signal energy.
So to start that, you want to go on hit acknowledge. You want to go into jog mode. And let's start by jogging axes 5. So go to joint jog. 5. And let's go down. Yeah, that should help you out a little bit. Okay. Yep.
God's good.
I know.
Figure it out.
Sometimes
It's all right.
You're in.
Why did you ask for help?
You're pretty close to it, right? I would recommend.
God!
Oh my
Nobody
god.
likes you.
You're right. You did it.
Correct.
See, I can go to the name. Once you have some of your life, then go to the video, and then you can bring it down.
See?
My persona is Elmo.
I would have went
It's time to get out of here.
2. Pinch, go to step mode.
Yep. We're going to do your Z. Space. Okay. Good. Then you want to click on your tool. You are. Cancel. You want to hit edit. Define. And this is where we're going to start defining our robots. So we need to go into the jogging menu.
Oh,
And then you want to get the robot as close to that tool as possible. Not tool. As close to our measuring device.
So sneaky. So sneaky.
Which is my.
Did you just say stop? I will go blue. Hey,
So be careful, Max. You're kind of bound up. That configuration is, it'll work, but you're close.
You're limited.
Yeah, you're very limited. That's okay. I would still touch it off.
A little bit more weird.
As long as it can
help me out,
you're good. When you want to do another position, don't be surprised if
You're still on position 1.
David.
you're out of range.
You're 4th already?
Yeah, you nailed it.
terrible man.
When he gets off games and gets on other games, oh, you weren't even near that.
Well, I'm focusing.
You were like a quarter inch off. That's fine. Let's see what your heat is going to be. 1.7. So we would say that's acceptable, but man, that's
pretty.
you can do better than that.
That was a score in
I'm
100 games. You're not the unbelievable.
doing well.
So put the quantity where you want.
Like I do like at week 8.
Toggle that?
Like
Set menu.
Wherever you put it. We're going to get
Right
it
now it's
out.
off. Right now it's off.
are you?
Sebastian, where are you at?
0.1.
You got 0.1.
I'm very exact.
We only gave you a couple minutes. You got okay?
You got 0.1.
That's okay.
Oh, he's one my God, David.
Yeah.
Control yourself.
Good idea.
Strength. You need to know your own strengths.
Very good idea.
I don't know anything
I will
though.
say that
So-
was your idea.
Very good.
I like it.
Oh no.
If they can get
I'm not responsible.
I might have. I'm gonna call our contact in Milwaukee.
Oh, yeah.
I don't know. There's some people that do that.
I like going like I like going on like that and then
Adrian!
Yeah.
I'll do that.
They're not. It's not E-stopped.
Adrian! What's wrong?
I have class next period here.
What's
That
wrong?
robot is in a horrible position. It is not safe. The E-stop is not on. Activated. Wait, what?
Oh.
Oh God.
Well.
So if you go to
Why are you going to
Trap.
and then
Well, I don't know what you're about to show me, David, but I'm glad you did it.
click
Rachel.
This is my
L position. There.
You guys were the whole question, man.
one task is running. Yes.
Okay, guys, E-stop. E-stop, put your controllers down.
Hey, see?
Stop it, you are being immature.
Stop.
Wait. Yes. Yes. I hope it ripped your pants.
All right.